Good afternoon. Are you guys? What are you doing, Ashanti? You all right?
I'm here, sir.
Yeah, I
Just a
don't know.
finish up some of the edible.
Yeah, but I mean, I am here. I'm sitting here from minutes to 1 o'clock, and it's now 1:30, and I don't understand. Ay, ay, ay. Right,
Evening, sir.
good
Afternoon.
afternoon.
Sorry.
Afternoon, Daniel. Mm. Ay, 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 ay. So we started differentiation last week, and we looked at the different rules of differentiation. And then we came across a past paper that required us to differentiate the square root function as well. Um, and this one was the root of 3x minus 12. The root of 3x minus 12. So today is um, April 22nd, 2023. Y is equal to 3x minus 12, the root of. Right. Y is equal to root of 3x minus 12. Okay. So now we have that function that we need to go ahead and differentiate. That is a square root function. And one of the things that you need to know about the square root function is the fact that whenever you have the square root sign, the root of x is going to be converted to x raised to the half power. Just remember that. The root of x is going to be converted to x raised to the half power. The root of x is going to be converted to x raised to the half power. Just remember that. Very important for you to remember. Can you see that?
I
Yes, sir.
see it.
So the root of x is going to be raised to x raised to the half power. Always remember that. The root of x is x raised to the half power. Now, if I give you y equals the root of 3 minus 12. It simply means that this is going to be 3x minus 12 raised to the half power. Can you see that?
Pretty much.
So that's what it is. And then this is what we're going to differentiate. And then this is what we're going to differentiate.
We just want everything on one line in bracket form.
So we have to do that minor conversion first before we go ahead and do the differentiation. Now the differentiation is going to be the same thing. The same thing as we would have done before. Y is equal to x to the n. Therefore, dy by dx is going to be equal to n, x to the n minus 1. Right? So y is equal to x to the n. Dy by dx is going to be equal to this n right here. X to the n minus 1. I'm reducing the power by 1. So it's the same thing that we have been doing. We are going to continue to do. Y is equal to x to the n. Dy by dx is going to be equal to n, x to the n minus 1. Watch me.
Sorry, applying the chain rule.
This one is going to be the power rule. This one is going to be the power rule. Something that is raised to a power other than 1. Yes or no?
Yeah, I said that.
Yeah, man. So the chain rule is going to be something in parentheses raised to a power that is not 1. It could be greater than 1. It could be less than 1. It could be a fraction. As long as it's not 1. If it is 1, then it's not the power rule. That would be the chain rule. But once it is being raised to a power other than 1, then we are going to have the power rule. All right? Very important. So watch what is going to happen now. Dy by dx is going to be equal to a half times 3x minus 12. It's going to be a half minus 1. It now becomes negative a half. Times the differential of the inside of the parentheses. What is the differential of inside of the parentheses? What is the differential of 3x minus 12?
3. But it takes a long answer. Jump and go to my laptop and come back is not easy.
3. So dy by dx is going to be equal to 3 over 2 times 3x minus 12 to the negative a half.
Sir?
So we don't normally write our index as a negative power. So we're going to convert. So recall, 1 over a to the negative m is equal to 1 over a to the positive m. All right? 1 over a to the negative m is equal to 1 over a to the positive m. Those of you who are coming out of pre-calculus would see that. For those of you otherwise would have seen or heard me speak about that before. Would have seen or heard me speak about that one from before. All right. So a to the negative m is going to be equal to 1 over a to the positive m. So because I have 3x minus 12 to the negative a half, in order for that to become positive, this is what I'm going to do. This is what I'm going to do. I'm going to say dy by dx is going to be equal to 3/2 times 1 over 3x minus 12 to the positive 1/2. Does that make sense? Talk to me. Does that make sense?
Yes, sir.
Yeah, because
All right.
because of differentiation and chain rule. Well, actually, I
All
have to
right.
turn it upside down anyway because it's negative 1/2.
It's a negative 1/2, right? And I don't want a negative. That's right. So we don't write our index as a negative power. We write it as a positive power. So we're going to change that. Watch what is going to happen now. I'm going to put these two together. So it becomes 3 times 1 is 3 over 2 times 3x minus 12 to the 1/2. But I still can go a little further by saying dy by dx is equal to 3 all over 2 times the root of 3x minus 12. See what I've done? I've reconverted it into the format that they would have given me the answer in the first place. I reconverted it in the format that they would have given me the answer in the first place. What they gave me was something in square root. They gave me something in square root. And I decided that I'm going to stick with what it is that they would have given me. So I am doing the question back into the square root format. Now remember, when I have the square root, it means that I'm going to convert it and write the term and raise that term to the 1/2 power. If I have the cube root, I'm going to raise it to the 1/3 power. If I have the fourth root, I'm going to raise it to the 1/4 power. All right, very important. And then when I raise it to the 1/2 power in this particular case, what I'm going to have happening is the function now is going to be in the power rule format. What is a power rule? The power rule is a term raised to a power other than 1. You have a term raised to a power other than 1. So remember, you're going to differentiate the term as a whole, and having differentiated the term as a whole, then you are going to differentiate what is inside the parentheses. So it's going to be 1/2 times
3x minus 12.
3x minus 12, and it's going to be n minus 1. So it's going to be 1/2 minus 1. 1/2 minus 1 is going to be equal to negative 1/2. Please remember, it's going to be a negative 1/2. So 1/2 minus 1 is going to be negative 1/2. If you put positive 1/2, you change the function. And then you are going to differentiate what is inside the parentheses. When you differentiate 3x minus 12, you are going to get 3. When you differentiate 3x minus 12, you are going to get 3. So we differentiate, and we got this 3 here. Differentiation ends in this line. Differentiation ends in that line. What we're going to be doing next is a bit of rationalization. We're going to fix up the question somewhat. So we're going to say 3 times 1/2. 3 times 1/2 is 3 over 2. See it here? 3 over 2. Times this function. But remember, that function is raised to the 1/2 power. Now, we are not in the business of writing the term as negative. We don't write the term as negative. So we're going to reconvert it. So I want you to recall a to the negative m When I reciprocate this function, it becomes positive. So I'm going to have 1 over a to the positive m. What I would have done right here is to convert my negative power, my negative index, into positive. I'd have converted my negative index into something that is positive. All right? Now, so what I'm doing, I'm now going to be converting 3x minus 12 to the negative 1/2 power. And this is it. So it becomes a positive 1/2. No. But I remember that I'm multiplying it by 3/2. So this 3 times this 1 gives me this 3. And this 2 is multiplied by this. So these two are being multiplied together. So I'm going to have them like this. And then the final step is to recognize that 3x minus 12 raised to the 1/2 power is the same thing as the root of 3x minus 12. So I'm putting it back in the form that they gave me the original question in 3x minus 12, the root of. All right? And this will be my answer. Any questions? Any questions?
No, sir.
Is there a past paper that anyone has at hand that they would want to share? You guys need to keep these past papers very, very, very handy, because I will be using these very regular in class and would want.
Yes, sir.
Yes, sir.
Exams like start like say the week after.
Exams start the week after what?
From today.
No, today's which day?
Yeah, 23rd. I think.
Yeah, I have 2 more weeks too. And that's why I'm a little annoyed that people come in a class after 1:30.
And I said I had some technical issues, sir.
No, and that's fine. But I'm just still annoyed that I'm here before 1 o'clock and I didn't have a class to teach. So we have 2 more weeks. And oh boy. Anyhow, it can be done. We have 2 more weeks, and we have today I'm going to start and end one of the topics that I know is coming. And then the other 2 weeks I just go through some other stuff. I'm doing 2 weeks of work with you. Well, from starting next week. It's important that we come to class on time so that we can accomplish what it is that we need to accomplish. When is the exam again, please? Which day?
For calculus 1.
Mm-hmm.
I tried looking in that document and I couldn't see it properly. I want to see
Anybody
The 18th.
the 18th?
Yes, sir.
So it means then that worst case scenario, I can squeeze in another Saturday the 13th as a revision.
Yeah, I thought a new document.
I sent you the final copy of the timetable,
No, I have it. That's why I said that. Because I was looking through it.
Mm-hmm. So we can have a date on I can't even tell you. So we can have a date early the 13th, Saturday the 13th, because Saturday the 13th. I have a foundation 2 exam scheduled for I think the 18th or the 19th. When is your exam, you say? The 19th or the 18th? Hmm?
18th.
Yours is the 18th. I have a foundation concept 2 exam, I think, scheduled on the 19th. Can you just check to see if the 19th foundation 2 is on the 19th, please?
Foundation.
Mm-hmm. Foundation 2.
Foundation. No, we say foundation concepts in math.
That's it. Foundation concept in math 2.
Yeah.
MATH 0002.
Yeah.
Which day?
The 19th.
Mm-hmm. Which is a day after yours. So I say this to say to you that more than likely I will be meeting with those foundation 2 students on the 13th as well. So the 13th is going to be a revision class, except no, but then again I can't do that. Yeah, I can't do that. Except that you guys can find a free day, a day where all of you are free, all of you are available in the week because exam starts.
The 18th.
No,
No, the
I think
15th.
the 15th. Examination period starts on the 15th. Oh, Rockstone, so your exam is in the first week. Everybody have exam on the 15th?
I'm looking through mine and I don't see any exam for me.
What about the rest of you in class? Can you open your mouth and talk to me, please? I'm trying to work something out for your benefit.
I'm fine. Everybody else can just use the chat.
Oh, let me just look at the chat. Okay, so Dana says she has exam. Okay, yes, sir, I have an exam on the 15th. All right, so 15 can't work. Do you have an exam on the 16th? Anybody here has an exam on the 16th?
16th. Oh, let me look.
All right,
Tuesday.
I think Dana says no. Check for me, please, guys. Let me tell you what I'm doing.
No, I
I'm
don't see
thinking
it. I don't see any
good,
for me.
good, great. Donald, how you stay? You have an exam on the 16th, so 2 persons
I'm
are
good.
clear. Or Donald is clear. Good. Dana, Donald, Crosswell, Daniel, Ashanti, how you stay?
I don't have.
Great. Ashanti, hon, how you stay? Ashanti, you're... All right. What this look like? All right. Okay. So my other question now is, I hear you that you don't have any exam, so we can sneak in a class. But here the critical question now. I know Dana, Donald, Crosswell are okay. I think Ashanti could be okay also. Daniel, will you be off on study break from work?
Repeat.
Will you be off on study break from work on the 16th?
I can arrange it.
Okay, all right. So this is what I'm suggesting. Tuesday the 16th, Lord Jesus, I pray to God that I don't have any meeting. But Tuesday the 16th, I am thinking that I could do like a marathon session. A marathon session where we just get past papers. I will spend about 2-3 hours and just work those questions. It may be difficult to be on campus to find a room, because when it's exam time, they cut off all the exam rooms. So it may be difficult for me to find a room per se, but we can do it online. But if it is that you want to have a face-to-face so we can just run through the stuff, I don't have a problem meeting with you on the 16th, where we can go through and get some revision done up. Let me ask the final question before I move on. Would you prefer, oh, remember that the exam is face-to-face here, guys. So would you prefer, and I'm thinking like a true teacher, because I understand that when you do, come to school, you're going to use up lunch money, you're going to use up bus fare, as opposed, if you're at home, you can, boil one egg and, draw two bread, slice of bread and I do that. Do you prefer the face-to-face or the online will work for you? Whichever modality works for me.
Online.
Online, okay.
I really want to spend
I
money.
understand. And that's why I said what I said, Crossway, because I was thinking of those persons who I know don't work, which is most of you. Spending unnecessarily when you know you have to go spend to come to do your exam, right? So we could meet online. So here what? I'm going to ask that you hold me accountable. I'm going to see if I can put it on my calendar on the 16th. I will meet with you guys. I have absolutely no problem meeting with you. And we just work the past paper questions to get to the point where we can go into the exam and pass it. All of us will pass the calculus 1. Every one of us will pass it. All right? I'm not playing with you now. I'm not going to pass my course. I'll move on and move to other things. All right? That out of the way. And worst case scenario, after the 16th, if I don't feel comfortable, we still have not the 16th, the 16th. Well, we would have had, I'm getting my cut material. Would I still meet on the 13th, Would I still meet on the 13th, Saturday the 13th? All right? And then now our final little wrap up would be on the 16th. And I'll do ask the same question for my to my foundation 2 group next week, God's willing, to see if I can meet with them just to finalize some stuff. Well, they are really on their way. I did some nice stuff with them and they're on their way. I have 2 more areas to finish off with them. All right. So with that said, guys, I believe you are also in a good stead. I just want you to get differentiation up and out. If you get your differentiation up and out, you're good to go. All right. Remember now, when I get the past papers here, because when we meet, I'm just going to ask if you just drop the past paper in the WhatsApp. I can copy it and share it on the screen while we do the questions. Right? Very, very important. Extremely important. All right. Let me give you a few questions to try on your own. And then we'll move into another area. It's very important, guys. I'm gonna start and finish another area with you today. Starting and finishing another area with you today. Right? Not a difficult area. But I need to spend quality time on this area because it's going to be on the exam paper. That much I know. Let's go. All right, where was I? Okay, so we got that. All right, so if you have any paper, remember to share them. Both of buff. Do know. All right, start for me, please. Start for me, please. Remember, Once you have the square root sign, it means that it's going to be the reciprocal 1 over. Sorry, so let me raise to the first, to the 1/2 power, right? Let me just put something here. Watch me. Recall the nth root of a will always be equal to a raised to the 1 over n. All right, that's the rule. That's one of the rules for precalculus. The nth root of a is equals to a to the 1 over n. All right, start with those two quickly for me, please, and then we can continue.
What did I miss? Oh, work.
No man, I just give you two questions to work quick and fast. Anybody is finished?
I got one, sir. I
All
got
right,
the
good.
first one at least.
All right, good. Do the second one now for me, please. Quick and fast. Quick and fast. Come, Donald. Run through them, Donald. Dana, run through them. Ashante, you're back. All right. Quick and fast. I'll give you a few more minutes. I mistakenly closed the, okay, mommy, no problem, the browser. So forgive me for stop sharing. I'm getting a little cold now. Oh crap. Oh man. All right. Dana, you finished the work on the screen. Done or they finish it? The other one to finish it?
Number 2, yes.
Um, I'm in class for oh no no, an hour, call it an hour 10 minutes, and the computer want to charge already. This computer don't keep charge at all. All right, let me do the first one, please, and then I'll give you a few to complete the second. Let me do the first. dy by dx. No, I'm going to rearrange. To say y is equals to 2x times x minus 4, x minus 1 to the half. What rule is this one now?
What do you call it? Power.
So the
Power.
product.
Yeah, product
Yeah,
rule.
yeah,
That's fine.
it's a product rule, but it contains a power in it. Yes. It's the power rule. It's a product rule, but it contains the product. The first times the differentiation of the second plus the second times the differentiation of the first. The first times the differentiation of the second plus the second times the differentiation of the first. First times the differentiation of the second plus the second times the differentiation of the first. So let's go. The first times the differentiation of the second is going to equal a half times 4x minus 1 to the negative a half, because it's going to be a half minus 1, times the differentiation of the inside, which is 4. So the differentiation ends right there. The first times the differentiation of the second. Then I'm going to say plus the second. The second is 4x minus 1 to the half times the differentiation of the first. And when I differentiate 2x, I'm going to get 2. So dy by dx is going to be equals to this 4 times this 2 will give me 8 times a half will give me 4. Talk truth. Boy, on a dead.
No, I'm still there, sir.
Me not get no vibe in the class. None.
No,
No
I'm
vibe at all.
just there knows where they're at now, sir. Got some to warm me up. Hmm.
So do you understand? Do you agree with what I have right there?
Yeah, much with my answer. At first, when I did it,
Mm-hmm.
um, when I did it, I didn't use the product rule, so I never get a proper answer. Because my first answer was 4 over 4x minus 1 to a half, and I said I couldn't write. And
Mhm.
and then you mentioned and then remember you mentioned the product rule, and that's what I decided to use.
Mhm. So you have to be careful and remember to use the appropriate rule. You have to remember to use the appropriate rule, because if you don't use the correct rule, the question is not going to be right. It's not going to be right. All right. So with that said, let me continue. Let me continue with this. So I'm going to be looking to see what is common and then factor out. What is common? What is common
Um,
here that is common there?
4x minus 1. But if you mean other than that, it would be the pause.
4x minus 1 to what power? You have two terms, Crosswell. 4x minus 1. And
One,
both terms are being raised to a power, so you can't just say 4x minus 1.
they're both being raised. They're both being raised to the power of of a half. One
No,
is
sir.
positive, one is negative. So
Right. So there are two different terms. So tell me what am I to take out?
the powers, the powers and them. So what? So as what I remember is that when you have similar powers
Hold
and
on, cousin.
eh?
But I take out the twos.
No, repeat that.
You would take out the 2 because 2 is in 4x. You can't take out anything from the powers because it has 2 different powers. It's completely different. So there's nothing similar to it.
And what would you do with the 2?
You would put back in the kit. That is what it's remaining. So you wouldn't trouble it.
Okay.
But am I able though? Am I able, Daniel, to take, all right. If I have a positive 4, am I able to take 2 negative 2 out of the positive 4?
Yes, sir.
Why?
Because 2 negatives make a positive.
All right, very good. I want you to think about that. Very good. Excellent. I want you to think about that. I want you to think about that now and answer the question that is projected. What is common between 4x minus 1 to the negative a half and 4x minus 1 to the positive a half?
4x minus 1, that's the thing. Wait. So what's common between them?
Four x minus 1 raised to the power 1.
No, you ask what is common between them.
Somebody talk to me, please. Jesus. What is common between them? 4x minus 1 to the positive a half, 4x minus 1 to the negative a half. Which of them do I factor out?
Greater 1, positive 1 with the positive a half.
When you're factoring out, what do? You take the smaller or you take the bigger?
The
Take out the
smaller.
smaller. You take out
You
the
take the
smaller
smaller.
term.
Okay, thank you. You take the smaller. Which of them is smaller?
Negative half.
Okay.
Oh, wait, the smaller term?
Yeah. The smaller term.
You would it would have to be it have to be two times 4x minus 1.
Okay, so hold on. So yes. So we hear that I have to take out the 2 because the 2 is common. So let me write that because I agree with that. 2 is common. And I hear that a 4x minus 1 is common, but I'm not sure what power. Which of the powers do I take out?
Negative half.
Negative a half?
Negative a half you have to take out because it's small.
All right, so I take out a negative a half. What do I multiply by 2 to give me 4x?
2x.
2x. So when I multiply these terms together now, do I get back this term up here?
Yes, sir.
Okay. What do I multiply by 2 times 4x minus 1 to the negative a half to give me this term?
4x minus 1 to the power of wait, no, that gave 1 times negative 1.
No. 4x minus 1 to the first power.
Huh?
Yeah.
Well, wait, sir.
I will wait. That's why I was waiting early because I want you guys to see it. Talk to me, guys. Talk to me. Time is going. Talk to me.
I'm starting multi-ton.
Dana, Donald. I don't even know who's in class. Okay.
Yes, sir. All right,
Oh, is
so
a three of you in class?
sorry.
Is a three of you in class? You see, not
Uh,
working out at all.
so that was always the case.
No, I mean, I remember seeing 6 of you or 7 of you. It has gone down to now 3.
Yeah, sure. It not really matter cause we there. All right. So for the first thing, let's see. So it would be 2x times 2. That'll give 4x. And that would be multiplied by the 4x1 to the negative half, which would give 4x times 4x minus 1 to a negative a half. Okay. All right. And then you would multiply. Oh, let me see something. Just so that I don't lose my head.
When I'm multiplying and the bases are the same, what do I do with the powers?
Add them.
Very good. So this will give me n plus n. So when I multiply, the bases here are the same, 4x plus minus 1. So 4x minus 1, 4x minus 1, those are the same bases. 4x minus 1 and 4x minus 1, same bases. All right? When I add these powers, negative a half to 1, what do I get?
Four x minus 1 raised to the power
A half. A half.
See it here? But even if you didn't know what to do, whenever we are factorizing, we always take out the smaller. Now, when we compare this to this one is smaller. So we always take out the smaller of the two. We always take out the smaller of the two. Talk to me.
I see. And since we have this, we can't what's the term, further factorize, no, simplify it down.
Yeah, man, it can be simplified now, because remember when it is raised to the, remember I was saying to you all along, when the power is raised to 1, is you don't have the power rule, because when it's raised to 1, I can remove it. So this is what is I now have. Dy by dx is equals to 2 times 4x minus 1 to the negative a half times 2x plus 4x minus 1. So I can remove this power because that power is just 1. That's the only time I can remove the power, when it is raised to the first power. Why? Because a to the first power is
A.
a. A to the first power is a.
When we calculate that.
A to the first power is a. Simple. Look at what's next. 2x plus 4x is 6x. So what I now have is dy by dx to be equal to 2 times 4x minus 1 to the negative a half times 6x minus 1. And this is now my answer. Somebody talk to me.
I had 6x, but I didn't have not. That's for sure. So my answer was incomplete.
How I feel other than that now though?
Well, it makes a useful research material.
All right. x squared plus 1 over x plus 1, x squared plus 1 over x plus 1. All right, go ahead with that one for me, please. The root of x squared plus 1 over x plus 1, which is this one here, x squared plus 1 over x plus 1. I'm just removing it from this side. Can I start working that one for me, please? I'm giving it 5 minutes, no more than 5 minutes. Can't spend the whole day on this. No more than 5 minutes. Start for me, please. All right. Are we finished now? Are we finished?
Yeah.
Go ahead, sir.
Okay. So when I rearrange, I'm getting I'm getting x squared x squared plus 1 raised to the half power all over x plus 1. X raised to the half power all over x plus 1. So I'm going to differentiate. What rule do I use for this one?
Go on, sir.
What rule do I use?
Quotient.
The quotient rule. Very good. The denominator times the differentiation of the numerator
Times the
minus the
numerator
numerator
times
times
the
the differentiation of
differentiation
the
of the denominator.
denominator all over.
The denominator to the power of 2.
Very good. All over the denominator square. So it's going to be dy by dx. The denominator, x plus 1, times the differentiation of the numerator, a half times x squared plus 1 to the negative a half times the differentiation of what is on the inside, which is 2x. So that's the denominator times the differentiation of the numerator. So that is the differentiation of the numerator. Then minus the numerator now. Minus the numerator, which is x squared plus 1 to the half power, times the differentiation of the denominator, which is 1, all over the denominator square, which is x plus 1 all square. So it's the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator square. Differentiation ends right there. All that needs to be done now is for me to fix up. All that needs to be done is for me to fix up. Let us fix up. 2 times a half is a whole. So I'm going to have this dy by dx. This 1/2 times this 2 gives me 1. And 1 times x is x. I'm going to have x times x plus 1 times x squared plus 1 raised to the negative a half power minus x squared plus 1 raised to the positive a half power all over x plus 1 square. Look and tell me if you agree with that.
X minus 1 over x plus 1 squared. Let's see. X.
Agree?
Yeah.
Sir, the only thing I didn't do is that I did not simplify. So you simplify 2x with a half and you get x.
Very good. Very good. So can I move on now?
Yeah, move on, sir.
Students, I don't know. This thing not work out, you know.
Mr. Open it, sir.
Huh?
Mr. Open it. I compare with my thing.
No, man. But I mean, keep me engaged now. Remember, I got 4 hours already this morning, you know. I'm up from after 5. I'm up from
Really?
after
Me
5.
too.
Yes, man. I'm up.
Really? Really?
Yeah,
Me too.
yeah, man. I'm up after 5 and I was doing some work, went into the washroom, did some stuff, get up, look after breakfast before my 8 o'clock class. I was in my class for 4 hours, left the place
That's
at a
why.
different location now, waiting for you to come. And you just not give me the vibes, you not give me the energy, man, for continue, man. You make me feel like more asleep now. I not lie you.
Truthfully, are they something more finished, but listen,
No, but irrespective of wanting to finish Edicus of Crosswell, all I'm saying to you, just keep me engaged in class, no? This is my second class for the day, no? My second class for the day. All I want you to do is to keep me engaged.
wait, hold on.
No, but I mean, we're doing this stuff, and I have to be asking the question 3, 4, 5 times before they respond to me, and that's not good. On not keeping me engaged, I feel like I want to sleep. The next thing I'm going to hear is me start snoring. I don't snore, but I may just start snoring, so they know I'm gone bed. No man, can't go on like that, man. Una have to keep me engaged. All right.
Oh, that means me the right then.
So what do I factor out? Is there anything that is common?
Oh,
So x plus
yeah.
1 and x to the half. So that can use, right?
What is common?
X squared plus 1 to the half. So that can use? Or like x squared plus 1
What do
only?
I factor out? Do I factor out the bigger or the smaller?
The
The
smaller
small.
term. Smaller term, sir.
So which is a smaller?
X plus, so to the negative a half.
Mm?
So to the negative a half.
X plus negative to the negative a half, right? To the negative a half. Is there anything else that is common?
Let's see. X plus
Is there
1.
anything else that is common?
X squared plus 1, sir.
No,
Because
there's nothing else that is common. Look at it. There's nothing else that is common. Look at it.
yeah, that won't work either. Come have a team, but no, hey, that won't work. What else will I be common?
What do I have left when I factor out the x squared plus 1 to the negative a half?
1. Oh wait, what? After.
You have x multiplied by x plus 1
Good.
minus
Minus 1.
minus x squared plus 1 raised to 1 power.
Very good. Very good. Very good. All right. And then now, remember, it is the power rule when it is raised to a number other than 1. So dy by dx a to the first power is a simple a is equals to a. So I can remove that. So what I have is dy by dx is going to be equal to x squared plus 1 to the negative a half into x times x is x squared, x times 1 is x, minus x squared minus 1. That cancels this. So I'm going to have dy by dx to be equal to x squared plus 1 to the negative a half times x minus 1, which is the same as dy by dx is going to be equal to x minus 1 all over the root of x squared plus 1. Look at that for me, please, and tell me that you agree.
Sir, I don't agree. Just a bit.
Why don't you agree?
Sir, I was just kidding. I agree with you.
Oh, okay, good job.
Sir, but I have a question.
Go right ahead.
Sir, I just realized say is x minus 1 because I was about to say when you flip it and you put the x squared, the square root on that,
Yeah, man.
you get a negative. So yeah. No.
Okay. So you're agreeing then, right?
Yes, sir.
Yes, sir, we agree.
Nice. All right, this is 2:47. I'm going to give you a little break. Resume at 3 o'clock.
Okay.
All right? All right, cool.
almost forgot poltergeist existed. Almost.
Are you guys back?
Here, sir.
All right. Does anyone have a copy of a past paper? Can share it in the group, please?
Sir, I don't have none, but I'm going to check.
All right. Thanks.
Sir, where do you ask? We just come up.
Past paper.
Oh no, the
You need to get past papers. Can't be doing a course and don't have papers to work from. So no, none of it can find any paper? That's what you're saying?
Sir, look in the chat.
Yeah, but
I
I'm not
sent in
seeing
your
it.
chat.
You know, what I saw in the, oh, in the, okay. He sent something in the WhatsApp group or the chat.
What's up?
He did on WhatsApp, sir.
Yeah, but that's not what I want. Yeah, that's not what I want, you know. I want to move on to another topic. You can do this one for homework. Um, all right. Yeah. All right. All right. Let us do this one instead. I'm giving you this, and we're onto a new area. Um, say y is equal to x squared plus 7x plus 12. Y is equal to x squared, right from it, y is equal to x squared plus 7x plus 12.
Y is equal to 7x squared.
No, y equals x squared. Going to differentiate that for me, please. Y equals x squared plus 7x plus 12.
Sir, plus what?
Plus 12. I want you to find dy by dx for me. Let me know when you have found dy by dx.
Speak louder, please, sir. Not here.
Y is equals to x squared plus 7x plus 12. Find dy by dx for me, please. Did you get 2x plus 7?
Yes, sir.
All right. I want you to set dy by dx to be equal to 0. Set dy by dx equals 0 and solve for the value of x for me.
So after we differentiate it, set dy to dx to 0 and solve x.
Yes, sir. See what value you got for x.
X equal 3/2. 3/1/2.
You're correct. Now, the value of x to be equals to negative, sir. You didn't say negative. Do you agree, Daniel, that it's negative 3/2? I mean, negative 7/2?
Yes, sir.
Mm-hmm.
Yeah.
All right. Now you're going to substitute that negative 7/2 into the original function for me. Into the original y function, x squared plus 7x plus 12, and 10 more to get.
Sir, x squared plus what?
Function, the original function.
Oh, the y equal x squared something.
Mm-hmm. Can't close it.
Sir, negative 0.25.
Everybody got that? Negative 0.25. I give them another minute or two to work.
I got 1/4, sir.
Same difference. Daniel, what you got?
I don't know how to work it.
Excuse me?
I don't know how to
Yes,
work it. I didn't get anything.
you are substituting x to be negative 7/2 into the original function. X squared plus 7x plus 12. So anywhere in y you see x equals 7/2, negative 7/2. Go for me, please.
Yeah, I did that, but I'm saying I can't go any further.
Why, Daniel?
So I'm still thinking about it.
When you square negative 7/2, Daniel, what do you get? Do you own a calculator?
I don't have it on me.
For me, please, so that Daniel can hear.
Repeat, sir.
I was asking you earlier if Crosswell could have, or if not, if Joe could have been 1/4.
Sir, I'm not sure if it's me alone.
You're not sure what?
If it's me alone, but you're breaking up.
Are you hearing what I'm asking just now?
Sir, no, I never heard you.
I'm asking for you to explain how it is that you got your 1/4 for Daniel for me, please. Walk him through the process. He doesn't have a calculator.
Sir, I use a calculator. Sir, hold on, sir, like, if he has a calculator on his phone, he can use that. what I did was punch in everything on my calculator and then I got the negative 0.
Mr. Him not have no calculator, so don't take him through that route.
Sir, I
And
don't
what
know how to explain it.
crossword can you explain it? You know, you guys not ready for the exam, you know, which is in
Sir?
another 2-3 weeks.
Sir?
Can you explain to Daniel how it is that you arrived at your 1 over these?
Oh, that. Okay. So basically, once I got the -7 over 2 from the derivative, I substituted got in that that is equivalent to x. Basically, what I did was just that I substituted it into the original function, which is y equals x squared plus 7x plus 12. And then once you do your calculations, that you would get, let me see. We'll write it down. It would be 7 over 2 squared plus 7 times -7 over 2 plus 12, which would be 49 over 4 minus 49 over 2 plus 12. And once you do your calculation, you're supposed to get 1 over 4 in my based on that. And that's how I got my answer. But if you're talking about the getting the derivative, essentially what you're supposed to do is that look at the original function. You have x squared plus 7x plus 12. And remember what sir said, any term with a power, you would multiply it by n and you subtract the power. So in case with x squared over 2, you would multiply x by that and you'd get 2x and then you'd subtract it. And then you'd basically get 2x1, which is basically the same thing as 2x. Same thing with 7x. Since it's basically just 1, you multiply that by the 7, and you would subtract it at the same thing, and you basically get 7. But 12 doesn't have an x beside it, so you can't include that into the next derivative. And once you accomplish that, you get 2x plus 7. And essentially what you do here is that see, you would set it to 0, so it'd be 2x.
Hold on.
Huh?
So hold on. So after you substitute it, you're going to differentiate it and leave off the 12.
Yeah, that's our original function, right?
Yes, so you're going to differentiate it after you substitute. And then you do the calculation. That's what you're saying?
No, you do the differentiation first. Then after you do that, you would set the
You substitute.
No, not yet. In reach to say it. First, when you have the y function, you differentiate that, and then you get the dy over dx. What you do that based on what sir is saying, you set that equal to 0, so it'd be 2x plus 7 is equal to 0.
No man, I get all of that, you see, and then I get -7 over 2. I substitute that in the function, and then what I do from there?
Basically you would find the values first. You'd find the values in the where you have x. So in my case, considering what I have, it was 7 over 2 squared, which gave me 42 over 4. And the next time was 7x.
49 over 4.
Yeah, huh?
Not 42, 49 over 4.
Yeah, 49 over 4. And then the next term would be 7x, and then I would multiply that by -7 over 2, and then that gave me 49 over 2. Well, negative 49 over 2.
Negative 49 over 2.
49 over 2. And then you just bring back 12 because you still need that for the function. And then once you have that, you just
and
solve
then you
it.
get 1/4.
Yeah, you basically that. You perform. You farm
No,
the
you'd have to add the 12 to it before you can get the 1/4.
yeah.
So what you're going to be having is 49/4 minus 49/2. The LCM there is going to be 4, and 4 into 4 goes 1. I don't believe that I'm doing this at this stage, honestly.
All right, thanks, Kwazo. I understand.
Okay. So what's the next one, sir?
LCM here is 4. 4 into 4 goes 1. And 1 times 49 is 49. 2 into 4 goes 2 times. And 2 times 49 is 98. And I subtract 1 from the other, I'm going to get negative 49/4. And I'm going to take down this positive 12. It's 12/1. LCM is 4. 1 into 4 goes 4 times. And 4 times negative 49 is negative 49. One into 4 goes 4 times, and 4 times 12 is 48. Negative 49 plus 48, I'm going to get negative 1/4. Matter of fact, did you all say a quarter or 1/4? What did you get? Negative 0.25? Because I'm getting negative 1/4.
Me talk, sir?
What you got for your answer?
Negative 0.25, sir.
Okay, negative, right. So it's a negative 1/4. I thought I was hearing 1/4 until I just worked it. So it's negative 1/4. All right. So now what you've just done is to find your critical point. What you've just done is to find your critical point. So your critical point here is going to be negative 7/2, comma, negative 1/4. Your critical, critical, your critical point. Give me another name for critical point. Give me another name for critical point, class.
Turning point, sir. Turning point.
Very good. Give me yet another one. turning point, critical point. There's another point to call it.
Is that the inflection point? Bye.
Why keep dropping on dropping off, Donald?
Internet phone in Kingston 20.
Okay. You did the same thing last week and never came back, none at all.
Local minimum, sir?
No, man. Stationary. It's a critical point, turning points, stationary point. Remember that?
Yes, sir. Yes, sir.
Yeah, man. Critical point, turning point, stationary point. All right. All right. So what I just did, all of what I just did right here is to be on this slide. And I wrote it on the other slide. So guess what? All right. So never mind. Let me just. I don't want to put the. I want the stationary point to be on 1. Oh Lord. That's what I'm going to do. I mistakenly showed it. All right, it's just going to stay here. It's going to stay there. All right, I'm going to write over what it is that I just did. I don't want it to be on that slide. I want the slides to be separate. So when you're looking at the stuff, you know exactly which slide to pick up. So this slide is supposed to be on stationary point. So what I would have done, and then I would say we are going to let dy by dx to be equal to 0. So therefore, it have allowed 2x minus 7, no, plus 7 equals 0. So therefore, 2x is equal to negative 7, and x is going to be equal to negative 7/2. So that's what you'd have done for the first part. Then I asked you to put x is equal to negative 7/2 into x squared plus 7x plus 12. And that would have given you y equal negative 7 over 2 all square plus 7 times negative 7 over 2 plus 12. That's 49 over 4 minus 49 over 2 plus 12. And then that would have been 49 over 4 minus 49 over 2. LCM is 4. 4 into 4 goes 1 time. 1 times 49 is 49. 2 into 4 goes 2 times. 2 times negative 49 is negative 98. And when I do all of that calculation, I'm going to get negative 49 over 4. And then now I'm going to take down to 12. And that's 12 over 1. My new LCM here is going to be 4. 4 into 4 goes 1 time. 1 times negative 49 is negative 49. And 1 into 4 goes 4 times, and 4 times 12 is 48. And negative 49 plus 48 is going to be equal to negative 1 over 4. And that's the value of my y. So what I'm saying to you now is that my critical point, critical, critical point is going to be x to be negative 7 over 2, comma, negative 1 over 4. All right? So that's my critical point. Then what I'm going to try and do now is to classify my critical point. I'm going to classify my critical point. Critical point CP, I'm going to classify it. What do you mean by classify? I'm going to classify it as being a local maximum or a local minimum. So Ashanti, this is what you're talking about. You're referring to local maximum, local minimum here. And this is after you would have found the stationary point. You now need to classify it. You need to determine if it's a maximum or a minimum. The maximum point will turn downwards and the minimum point will turn upwards, right? So that should be a max and this would be a min. So the graph turns downwards, it's a maximum point. The graph turns upwards, it's a minimum point. Following so far?
Understood, sir.
Say it again.
Understood.
Okay. You know, somehow I don't know how I get fell asleep, sir. What's what you say? But you said understood. Any other question? Any other comment? Are you following what I'm talking about?
Yes, sir.
Yes, sir.
All right, good job. Now, I'm going to find the second derivative. When I classify my critical point, I'm going to find the second derivative. So I'm finding d2y by dx squared. I'm finding the second derivative. It means that I'm going to differentiate the first one more time. So this one, I'm going to differentiate one more time in order to get my second derivative. When you differentiate 2x plus 7, what do you get?
2.
2. So dy by dx is going to be equal to 2. dy by dx is equal to 2. Is that a positive 2 or a negative 2?
Positive 2.
Right. So since positive, we have a local minimum.
Because positive values go up on
a minimum. Right. If it was negative, you'd have a local maximum. So because it's positive, you have a local minimum. Please note if the value were negative, comma, then you would have a local maximum. All right, so please note. So the value is positive, you have a minimum. Negative, you'll have a maximum. Are there any questions?
No, sir.
In a nutshell, that's what we're going to be doing for the rest of the remainder of the class. I'm going to give you a function. You're going to differentiate the function. You're going to set the function equals to 0 to find the value of x or values of x. Either value or values. In this case, we got a value. More often than not, you're going to get values of x. We're going to be getting the values of x. And when you get the values of x, what is going to happen is that you're going to substitute both values of x, which are called the critical values, not the critical point, but the critical values. Those critical values are going to be substituted into the original function like we just did. And when you would have substituted into the original function, what you're going to end up getting now is the corresponding y value. And together, those points will be known as your critical points. Those points will be known as your critical points. Now, in order to get your local maximum or local minimum, you'll have to go ahead and find the second derivative. You'll have to go ahead and find the second derivative. In finding the second derivative, you're going to also set that equals to 0. But in this case, we got the second derivative to be equals to a whole number. But in the other example to come now, you'll see exactly what I'm going to be talking about. So let me see if I can generate rather, a question for you. Yes, sir.
This example has one critical point. So in the next example, you're going to have 2. That's right. Where if you have 2, you're going to set the second derivative to 0.
Right. So when you have one critical point, you're not able to get that second derivative to be equal to 0. Yeah, about it. So when you have one critical point, it's a pretty easy question, and I don't expect you to get a question with just one critical point. They will not set a question with one critical point. You're going to get a question with 2 critical points. All right. So write this one down for me, please. X cubed minus 3x squared minus x cubed minus 3x squared minus 24x.
Guys, repeat that.
X cubed minus 3x squared minus 24x.
What's the answer? X equals 4 and minus 4. Oh, nobody hears me?
I hear you saying something, but I'm trying to pick up what are you saying.
Oh, is the answer are the answers x equals 4 and minus 4?
4 and minus 4? All right. I've not done that yet. I'll tell you in a few. So we have
So
y
you're talking
equals,
when you set it to 0?
no man, it's stationary point, you know. You have a question on stationary point. In order to do the stationary point question, you have to differentiate.
Yeah, I did differentiate.
What you got when you differentiate it?
I got x. Yeah, sorry, I got x times bracket x minus 8 and x plus 3 in bracket. Let me just see if me and you have the same y function.
Yeah, 6x minus 10.
That's what I was expecting you to tell me you got for the answer when you differentiated it.
And 3 times 24x.
Sir, I got 3x squared minus 6x minus 24.
Right. Good. That's what you're supposed to get, yeah. And then now, I'm going to put dy by dx to be equal to 0 and solve. So I'm going to say let 3x squared minus 6x minus 24 equals 0, because I'm now solving for the values of x. So I'm going to set the derivative to be equal to 0. So that's the next step. So having differentiated, the next step is to set the derivative equal to 0 and solve for x, solve for the unknown. Set the derivative equal to 0 and solve for the unknown. Set the derivative equal to 0 and solve for the unknown. But look at what is going to happen. I'm going to divide through by 3. Why, sir? Because I will simplify my equation to work with. 3 is a factor of this equation. So therefore, because 3 is a factor of it, I'm going to divide through the equation by 3. I'm able to do that only because it's an equation. I would not have been able to do that if I had an expression. But I'm going to divide through by 3 to simplify my function. So this is going to become x squared minus 2x minus 8. And that's equals to 0. Now I need to factorize that function. X squared minus 2x minus 8. I need to factorize that.
Minus 4 plus 2.
I need two numbers. When multiplied together will give me negative 8.
Yes.
Sorry, let me start. I multiply the coefficient of x squared by the constant. The coefficient of x squared is 1, which is the number in front of x squared. And I multiply that by 8, by negative 8 to be exact.
Yes.
And I get 8. And then now tell me the two numbers now. Two numbers when multiplied by
Negative 4 and 2.
You get
Negative 4 and positive 2, sir.
Very good. So the factors are negative 4 and positive 2. So I'm going to rearrange to say x squared plus 2x minus 4x minus 8 equals 0. When I group, I'm going to get x squared plus 2x in one bracket. I'm going to leave out my middle sign every time. And I'm going to have 4x plus 8 in that other bracket. Sir, why did that 8 change from being now negative to now positive? Thanks for asking. Because I'm factoring that negative sign out. I'm factoring out that negative sign. So in factoring out this negative sign, I'm factoring out the negative sign from here. That means we're going to become positive. Because remember, Daniel, you answered the question earlier. in every positive number, there are two negative numbers, this one and that one. And whatever sign that is here has to be the same sign that is here.
Sir,
Mm-hmm.
sir, you lost me with the sign. You can go over that, please?
I'm factoring out a negative sign from here and here. I'm factoring out a negative sign here and a negative sign here. When I factor out a negative sign here, what two numbers are multiplied together to give me a negative number?
Oh, for God's sakes. Oh, for God's sakes, a positive and a negative.
A positive and a negative. And if I have the negative, this negative sign right here, that means the other side has to be positive. And if I have a negative sign right here, that means the other side has to be positive. So what I'm saying to you, I'm factoring out a negative number. I'm factoring out a negative number. And since I'm factoring out a negative number, it means what is going to be left will be a positive number. So for every positive number, there are two negative numbers inside of it. So if you look at 4, for argument's sake, positive 4, there are two negative 2's inside of it. Similarly, there are two positive 2's inside. So negative 4 has one positive 2 and a negative 2 in there as the factors. Because the mere fact that it is negative, it suggests that one of the factors is negative and the other factor is positive. Once it is that the number is positive, it means that it has a pair of negative numbers contained, similarly a pair of positive numbers contained. Am I making sense?
Right now you are, sir.
Yes, sir.
All right, good. So therefore, what I will now do is to say what is common between x squared and 2 would be x. What is left is going to be x plus 2. What is common between 4x and 8 will be 4.
4.
What is left is going to be x plus 2. What is common between x plus 2 and x plus this side and that side will be x plus 2. What will be left? Will be
X plus 2 and x minus 4.
I notice each of those equals 0.
Yes.
Each of those equals 0. Each of those equals 0. Each of those equals 0. So either x plus 2 equals 0, which implies x is equal to negative 2, or x minus 4 equals 0, which implies x equals 4. Those are my critical values. Those are my critical values. What do I do with those values now? Based on the question we did before.
We would
Put it in the y function.
Yeah. And then based on that, we'd use those to determine the minimum and maximum value. Sir?
Hello?
Sir. Sir, now here we. Mr. Mark. Mr. Mark.
Hello?
Mr. Mark.
Sir, hearing?
Hello?
Sir.
Not hearing.
On.
Are you hearing me?
Sir, you're not hearing
Okay.
us?
Yeah, but you see, you know, the honest truth is, me now look on the, me now, me, when you know me at the chat already, and when you talk to me at the chat, I mean, I don't know, I'm going to start talk to you in the chat. I'm going to say, you not going to understand the maths.
Sir? Sir? You hearing us?
And I'm not hearing if you're speaking. I see your mic going, but, oh my Lord.
Oh.
All right. Are you hearing me now?
Sir, we are hearing you.
Okay, I'm hearing you now. I wasn't hearing you at all. All right.
So we put the x values in the y function.
That's right. That's what I was giving you time enough to do. And then I heard perfect silence. So I was wondering. All right. So I'm going to put x equals -2 into x cubed minus 3x squared minus 24x. So therefore, y is going to be equals to -2 cubed minus 3 times -2 squared minus 24 times -2. Y is equals to -8 minus 12 plus 48. Check for me, please, to make sure that I'm correct. Can you double check, please, to tell me if my points, my critical point there is correct?
What X? On. Let's see. That before. -12. Okay. 48. Okay. -2 cube is -8. All right. Okay. Can you still hear us, sir?
Come on, loud and clear.
Yeah. -2 cube is -8. 3 times -2 to the fourth is 12, which would be in this case minus
3 to the
minus
fourth.
12.
3 to the fourth is not 12.
No,
Three
that's
to-
no, that's not what I said. I said 3 times 4 gives you 12.
Okay.
So that would be -8 minus -12, and negative times a -4, 24, and 2 gives you a positive, so that would be positive 48. And then you would have let's see, 8 minus
-20
negative
plus
20 plus
48.
48 equals -28.
-28 plus or positive 28?
Positive 28, sir.
Mm-hmm. Very good. So the critical point is going to be negative 2 comma 28. Negative 2 comma 28. Do me a favor. I want you to do the other one for me. When x equals 4. Do that. I give you 3 minutes to evaluate that for me, please. Did you get negative 80? I think I did something wrong.
That's what I got, sir.
Anybody else got negative 80?
Yeah. There are lots of people to say it now,
Sir, I
chat.
got
Yes, sir.
negative 48.
Shelly said she get negative 80 Crosswell on me. Check again, Daniel.
Sir, I got negative 80.
4 to the third is 64, you know. And 4 is 16, and 16 times 3 is 48, and it's a negative 48. And 24 times 4 is 48, and 48, 96, negative 96. Yeah, man, it's a negative 80, because if I take 16 from that.
Yeah, negative 24. Mistake. Yeah, man, I'm
Right,
doing a mistake.
right. So negative 80. So my critical point.
Don't worry yourself, Mr. Shine. Don't worry yourself.
All right, hold. I get 4, negative 80. So I get 4, negative 80 right there now. All right, and then now to classify,
Mistake.
we're going to find d squared y by dx squared. Just remember, once I ask you to classify, you have to find d squared y by dx squared. So recall dy by dx is equal to 3x squared minus 6x minus 24. So therefore, d squared y by dx squared is equal to 326x minus 6. Dark truth.
Yes, sir.
Set that equals 0. That means x equal 1. Talk to me.
Yes, sir.
No, you're going to put x equal 1. You're going to put x equal 1 into, what was y again? X cubed minus 3x squared minus 24x, or so? All right. Substitute x equal 1 for there for me, please, and let me know. 3 minutes. You get negative 26?
Yes, sir.
Yes,
Mhm.
sir.
So y
Sir, I
equals
got
negative.
negative 32.
You get 32?
Yes.
How so? One you're putting in is one was putting in? Yeah, x equal one you're putting in, miss. So 1 cube of 1. 1 squares is 1. 1 times negative 3 is negative 3. 24 times 1 is negative 24. 1 minus 3 is minus 2. Minus 2 minus 24 is minus 26. No, man, Joe, check again. Minus 26.
Sir, I got the 26.
No, still wrong. Supposed to be negative 26.
Sir, that's what I said. Negative 26.
They say, Joe, at 26, you see how that's going? But anyhow, negative 26 is correct. All right. All right. So guess what? I went ahead of myself um, in this question because this is not, this is me when I go to this length to do, sorry, all of this is actually finding the point of inflection. So let me classify the point. I actually jumped ahead of myself. So um, I'm not going to put x equal 1 right here because I'm actually classifying the point. What it is that we did a while ago with the negative 26 is correct, but it's for another question. For another question. For another question. All right. So let me just put
So
another slide in
what is
between.
it for?
The point of inflection. But
Okay.
I'm coming back to it. We're not wasting it because we're coming back to it. We want it, so we're going to come back to it. So for to classify the point, dy by dx, anywhere in it we see x, we're going to substitute the critical point. Now we have two critical points, negative 2, 28, and 480. So d squared y by dx squared is 6 times negative 2 minus 6. And this is equal to negative 12 minus 6, which is a negative value, negative 18. So this is a maximum. Right? And then d2y by dx squared is 6 times, what the other one now? Other one is 4 when x equals 4. Minus 6, 6 4 is 24 minus 6 is equals to positive 18. Of a local minimum. Of a local minimum. All right. So I know that it's a local maximum when it is 4 negative 80 is a local maximum, and local minimum is negative 2 comma 28. I think it was 28. Yeah. So those are the, so that's how you classify the point as a local maximum or a local minimum. Local maximum or local minimum. Now, to do the point of inflection, you're going to find d squared y by dx squared and set it equals to 0. So therefore, this is how we're going to get the 6x minus 6 equals 0. 6x is equal to 6. X is equals to 1. And then now we're going to put x equal 1 into all of that and we'll get negative 26. My point of inflection is going to be 1, comma. So point of inflection is going to be 1, comma, negative 26. All right. So let me go again. I'm just looking at a story here. A bus on Spanish Town Road got shut up. Anybody heard about that?
No, sir.
What am I tell you? You guys saw the accident in the toll plaza?
I think I heard about that.
Oh my Lord. I don't know what is happening to us, honestly. Oh goodness. I really don't know what is happening to us. Anyhow. So when you differentiate the function and you complete a differentiation and you substitute, when you substitute the values into the function, you're going to end up getting your critical points. I have 2 critical points. But as soon as I get my critical points, I must classify those critical points. Classify them as being local maximum or local minimum. In order to classify them, I'm going to find the second derivative. So I'm going to differentiate the function again. And the second derivative is going to give me 6x minus 6. So what I'm going to do is to substitute the values of my critical points into the function. And it tells me if it's positive, it's a local minimum. If it's negative, it's a local maximum. So I'm substituting my x value here, which is -2. Let me go here. When I substitute my -2, I'm going to get a negative value. It's a local maximum. It's negative, so it's a local maximum. In the same d2y by dx squared, I'm substituting my 4. Are you here, Donald? I'm substituting my 4. When I substitute my 4, I'm going to end up with a positive 18, a local minimum. Donald gone again? No, he's here. I'm going to get my local minimum. So those are so I'm able to classify, because I need to classify those points because I'm going to eventually sketch the graph. And in sketching the graph, I will need to ensure that my maximum point and my minimum point are exactly where they are supposed to be. Are you following me?
Yes, sir.
All right. I'm going to give you one to do, I'm going to give you one to do. All right, let's go. And then the point of inflection now is that's the point we're working at. The point of inflection, you're again going to find the second derivative, but you have found the second derivative already. So you just put it equals to 0, you're going to get x equal 1. When you get x equal 1, you're going to substitute that into the function. That gives you the point of inflection. That gives the point of inflection, right? And then, let me just give you this little piece here, because this little piece is kind of sweet. We can ask you to find the y-intercept. Y-intercept. The y-intercept is found when x equals 0. This is found when x is equal to 0. So the original question is y is equal to x cubed minus 3x squared minus 24x. Anywhere in the function, you're going to let x equal 0. So y is going to be equal to 0. So the y-intercept is going to be 0, 0. The y-intercept is going to be 0, 0. Are you with me?
Yes, sir.
Yes, sir.
All right, good. Now, I think I have enough information to sketch my graph. I could ask you to find the x-intercept, but let me just leave that for now. All right, let us do it. No, I'm not going to do it because that's a cubic equation, and it's only the pre-calculus students would have done synthetic division to get that cubic thing solved. So I don't think that we're going to give you guys this to do. So all right, let us stay. Let us sketch the graph. Let us sketch. So we have a few points that must be on the graph: -228 and 4, -80. -2, 28, 4, -80, and -228 is -228 is a local maximum, and the other one is a minimum, and 0, 0 is a y-intercept, and then my 1, -26 is my point of inflection. So when I'm sketching the graph, it's not a plot, it's a sketch. So this is my y-axis. That's my x-axis. Right? Now -2, 28, I'm going to call about here. So it's a sketch. I'm estimating where 28 is going to be. So -2, 28, there. So 4, -80 is somewhere down here. So, but -228 is a maximum. That means it turns down. So that graph turned down somewhere. And the 4, -8 is a minimum, so it turns up. We know that the minimum turns up. We know that the maximum turns down. See it here, so the minimum turns up and the maximum turns down. So this is why I gave you this here, to show you that max turns down. Look, maximum is like a negative graph. It turns down, n for negative. All right? And the minimum graph turns upwards. So you have to know the shape of those stuff. What turns up, what turns down. So I know the shape of those. And of course, my intercept is 0, 0 right here. So I know you can pass through here. So I can go safely and say ropes, and this go up so. And I'm not going to carry it and make it touch the x-axis because I don't know where it cuts on the x-axis. But that's a general sketch of my graph. And that's what the graph will look generally like when you sketch it. Fair enough? Make sense?
Lot of sense, sir.
All right. I am going to send you this document. I'm going to send you this document because I'm going to also generate another question for you. And I send you the document so that you can have the document to look at, for while you do the other question for me. And then that should take us up to the end of the class. So I just have one more question to do. Well, you have one more question to do. And then that should take us up to the end of the class. And I also want you to do the sketch. All right. So I am giving you this question. Let me give you that one. Write this one for me, please. X cubed plus 6x squared plus 9x plus 4. X cubed plus 6x squared plus 9x plus 4. X cubed plus 6x squared plus 9x plus 4. X cubed plus 6x squared plus 9x plus 4. All right. Let me send you this. I need to go on.
Yeah. Sir, one more thing, sir.
Go ahead, Papa.
I was checking the calculus 2 section for it and for Edgar's and there's something that I was talking to you about last week, sir. I was wondering if you still remember about it.
Yes, Crossword, I have.
Okay.
Let me see if this has been updated. How many slides I have? I have 6 slides. Just checking to see if it has updated. Second. All right. Sending this document to you now, so that, as I said before, who are you? Calculus 1. So that you can start working on those for me. Not those, but that one. Last question before we end class today. I also need to. I think I'm in one position too long. I need to go and stretch my legs, but I'm going to sign into another device. Where am I? Class list. All right, start working for me, please, guys. Start working for me, please.
Recording in progress. Hi guys, how are you going? Okay. All right, I
My
see your
answer in the
response.
chat.
I see your response, Joel. I don't check it yet, but giving the others an opportunity to finish off and then the rest of the panel check up. Um, up guys, hurry up, please, hurry up. The rest of you. The rest of you, are you finished with the stuff? Or are you still working? Hello?
I'm finished, sir.
Another 2 minutes or 3 minutes? Are you finished now, guys? I'm not gonna give the
Yes, sir.
solution to the. Yeah, I know you're finished, no, but I'm not gonna give the solution to the question if you don't do it, So I want to see. Matter of fact, you know what I want to do? I want to see you. I, I want all of you to submit the solution to me before I actually send my solution out because they need to be doing some work. So I want to see the solution submitted to me first before I send you my solution. By the end of the class, I would expect you to submit something to me. Um, what I will do is to look at it and I respond to you in a few with the solution, just as I sent you one just now. But I need to see the work done up, please. All right, guys. I'm going to end this session now, but I expect you to submit the solutions to me before the day is out. Remember, your exams are in another 2 weeks. We have to commit ourselves to doing this. I will do the solution, and I will send off to you, and then and we can have conversations about it. All right. So Crosswell, you have the host key. Can you end the session for me, please?
Sir, hold on. Sir, I have to resend mine or what I have is fine.
No, man, no, man. I've seen. Oh, crap. Yeah, you sent it in the chat, right?
Yes, sir.
Please resend it. Put it in the WhatsApp for me, please, there. Sorry about that. All right?
Okay, sir.
Okay, hopefully. Crosswell, you can go ahead and end the session for me, please.